This is an amazing session. I'm really excited. Hey guys, welcome to this amazing LinkedIn live session on generative AI. Today we have a very special guest. You already saw her, she's here. Uh, but let me reintroduce her for all the great work she's known for. So today's guest is none other than the famous Priyanka Vargadia. Priyanka is Senior Director of Global Developer Engagement at Microsoft. Previously, she led the Google Cloud Developer Relations team. She is a tech leader with 15 plus years of industry experience, and she's the author of the number one best-selling book, Visualizing Google Cloud. She's a well-known thought leader in the developer community with 200K plus followers across her social media channels, and she has a passion for simplifying tech concepts in visual storytelling. And she has a YouTube channel, you all know that, and a blog focused on cloud and AI with thousands of subscribers in the developer community. So yeah, welcome to the live session, Priyanka.
Thank you so much, and thanks for inviting me for your show. I know you've been doing this for quite some time, and I am honored to be on here today. And thank you everyone for joining. We did this in multiple ways and had two different links, so we apologize for all the technical
Yeah.
um, you know uh, delays in starting this, but very excited to be here, and I think we'll continue to have people joining in from that link to this link. So apologies in advance for helping people out, getting it to the right place.
Yeah, thanks. I'm really excited. So I've been following you from last, I think, 5, 7 years. So we all know that Gen AI has taken the world by storm, but many people still don't know how to and where to start their journey, their generative AI journey, understand the concepts and also. Today's session should give you all an overview of how to navigate your Gen AI learning journey. So, like I said, I'm waiting to hear Priyanka. And Priyanka, my first question to you is like, what is generative AI?
I think most people have at least tried to have their own definitions at this point, right? Anything where models that can help generate text, video, unstructured data in a lot of ways is what generative AI is. But I thought we can get a little bit of, very few people sort of understand where it fits into the the broader ecosystem of AI and models and machine learning and traditional machine learning and all that. So I wanted to share. Let me
Yeah,
bring up
please.
my slides here. I have a visual because hey, I don't talk without visuals, so I had to have some visuals here. So here we go. So I was you guys see it, right? Yeah, there it is.
Yeah,
I'm not going to go full screen because I think this is going to give folks enough context of what I mean. So this is what generative AI is, right? Like the overall, the overarching, the biggest circle out there is the artificial intelligence, which is nothing but human-like intelligent systems, right? Then, when we talk about machine learning, that is the subset. And by subset, we mean the algorithms that then learn from the large data sets that we provide. This is the idea where I'm sure everybody has seen, you're giving labels to images and text or content, and then asking the model to tell you, what did you just see? Was it a dog or a cat, right? This is that traditional machine learning, but that's kind of where the algorithms sit in the machine learning circle of this mental map, if you will. And then comes the neural networks. So the neural networks are this inspired algorithms inspired by the brain and how our brain works with the neurons, and consists of many layers, and that is what neural network is. So, and then generative AI is even inside of neural networks, which uses the neural networks to generate the new text, the new images, and the other media that we are all getting to use and enjoy in current times with ChatGPT and Gemini and other services. But that's kind of where it sits, and is able to use the neural networks and the algorithms, machine learning, and so that's the level where we are at. And then the large language models is really just one type of generative AI, which is really only for text. So when we talk about text, that's when we're talking about large language models. But if you're talking about images and other media, then it fits into that Gen AI category with all the different unstructured data. Hopefully this helps. Does this help give a little bit of a map of what where we are at with Gen AI and where it fits?
Yep, yep. Yeah, so since many advanced LLMs pop up very often these days, we see a lot of GenAI applications getting built. So my next question is the GenAI hype real? Why is it getting so popular these days?
So um, I think we are past the, and I know some people might kill me for this, but I think we are past the hype, right? I think we're definitely starting to see use cases of generative AI
Mm,
that are very nicely affecting how we do business. And that in itself is saying that it's not just a hype at this point, right?
mm,
And the second way to look at it from like not a hype perspective is the amount of innovation, the amount of research that's happening, the number of models that we are seeing. I mean, we just saw DeepSeek R1, and
yes.
then just yesterday we saw another model that they dropped, and then Alibaba dropped another model too, and just the advancement is so fast that there's definitely we are past the hype. We and when research is moving fast, it's
Mm,
definitely past the hype, right? So that's one way, but the other one is the visual that I just pointed out. The reason why common man and is excited about this is because earlier we weren't able to use the traditional machine learning models, were always just being used by machines, by our use cases, through either data scientists or machine learning engineers, right? With Gen AI, it's been possible for because it's possible to interface with Gen AI through natural language. We are able to make it more accessible to a larger set of people who don't have to be data scientists, who don't have to be machine learning
mm,
engineers, and don't have to think about it's basically like the internet, which everybody and anybody can use. You don't have to be a computer science person to be able to use the internet. And the reasoning engine behind the generative AI models is what makes it even more powerful, and what's changing the game for becoming more applicable to everyday tasks, because it can reason. And earlier it used to be, I would like you to do x plus y, and you just get the x plus y back. But that's not machine learning, right?
yeah.
So the reasoning engine and the natural language combined together, and the pace of research that we are seeing, I think that is what takes us beyond the hype.
Okay. Yeah, I mean, I see many traditional companies also started using Gen AI in one or the other ways lately. So my question is, why do we need Gen AI? Is that these companies just want to be with the hype cycle, or no, it's a reality now? Or what is the reason? Like, why do we need Gen AI basically?
I think the it's not the I think the I would ask the question differently. It's 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 not why do we need Gen AI. I think i think every single leadership role person in leadership today should be asking this question: why do we need Gen AI? And do
Mhm.
we need Gen AI, right? Like, because everybody is trying to just run in the race and want to have something about Gen AI into their product portfolio. And when I when I when I'm working with customers, talking in to folks, the biggest thing that comes up is like, we just want to do something with Gen AI. And this was the case few years ago when we were talking. We just want to do something with AI, and now it's become, we just want to do something with Gen AI,
Gen AI.
right? And so you have to go back and give them this whole spiel of, you actually you actually start with the use case. What do you
Mhm.
what do you want to accomplish? And then go back and see if that applies to, if Gen AI is the tool to solve that. I posted something a few days ago, from and we were sitting in a class with Professor Stefano at Wharton, and he had shown us the drill machine. And I think this is such a great example to bring up. So he showed us a drill machine, and it was put in a really nice pedestal, right? You don't buy a drill machine to put in a pedestal. This is exactly why, if you translate that to Gen AI, you don't have that to put it on a pedestal. You actually buy a drill machine when you want to poke holes somewhere. So
Got it.
what are these holes, and how is the drill going to help you make those holes, is what you need to think about, right? And so I keep going back to that analogy, or any analogy where you're able to explain what is the use case, what are we trying to solve. And if the use case is, yes, I want to I have large number of PDFs and I want to summarize them. I have text and unstructured data all over the place, and I need my employees to be able to sift through that quickly and ask questions about this and that. If you have specific use cases, go back to, like, these are the use cases I want to solve, and then Gen AI would be just a tool to help you solve that. Does that?
Yeah, 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 yeah.
Yeah.
So you are telling do the reverse engineering, ask the questions, and then and
Exactly.
it's also okay to not be in that fit of just using Gen AI because not every company might not need Gen AI sometimes.
Exactly. And this goes to the fact that you may not need it today.
Today. Mm.
Get yourself educated on what Gen AI is and where it's powerful, what are its good use cases, what are the gotchas, right? Which is exactly why we do, like, this session, the courses. Like, I would go ahead and get myself educated on all of that, so that when the time is right, when I have the right use case, I'm educated enough to make the decision of using the right tools.
Right, yeah. Also, when we know that the base of all these modern LLMs is this thing called transformer model, right? So, can you tell us a little more about the transformer architecture?
Okay,
That'll be
yes.
more interesting.
Yes. So before we get to that, I want to actually show something for folks who are new to, even, like, just Gen AI, large language model. Let's do a little bit of a, start like 2 steps before then. So when you and most of us are familiar with, like, ChatGPT example, right? You write some text, that is the input, and then it goes into the model, that's the middle section there, and then model returns you some output. You see a bunch of text that it generates. The way that happens is the model is actually not generating the entire text all at once. It is generating one, the next word, and then it feeds back into the same input cycle. So here, if you look at the example, if we take this example of, we were climbing the next word of what are we climbing is what the model is going to predict. And And so it looks at, we were climbing the hill, mountain, tree. Those are the possible outcomes. And then it goes back and it looks at the data that it was provided with the large number of books or magazines or articles, wherever we got the data from, and we trained the model with this data and context. And we apply techniques like the next word prediction technique, where it predicts the next word off of whether it's a hill or a mountain or a tree. And then it picks that one word, mountain. And we're not going into details of how it picks the mountain, but it's really a probabilistic model where it selects one of the highest probable words. And then we and then it goes back into the same loop to the input and says, we were climbing the mountain, now give me the next word after that. And so that is the iteration that happens before. But you just see the entire text showing up when you type a question in ChatGPT. But that brings me to then your question back, which is what are transformers or the
Mm,
transformer architecture. Before transformers, well, first of all, why do we need transformers is the question that most people ask. Before transformers, we were living in the world of recurrent neural networks, and recurrent neural networks were, again, just like I showed you this picture. It is a neural network that also was tried to be used for next word predictions. The challenge with that was it was very expensive and memory constrained. And here's why: because our languages are very, very difficult to learn and understand. Here are two examples I have on this slide where it's like, she saw a bat. Is bat an animal or is bat sports equipment? You don't know that until you have additional context. And that is called homonyms in English language. And then same thing around ambiguity. It's like, I saw the person walking with binoculars. Was the person walking with binoculars, or was I walking with binoculars? It's unclear until I know a little more about this whole context. Like, maybe there's like four paragraphs before this that tell me more about the walk that's happening, or there's an animal in the picture too, or something's happening, right? But we don't know that with just this sentence. So recurrent neural networks are memory constrained. They cannot work with they could only work with this limited context, and it wasn't possible
mm,
to know more, and which is why they were not very efficient, and also resource intensive. So transformer architecture solves this problem of additional context. It does it at scale. You can parallel process, so not just one sentence. You can have multiple different parts of the book, parallel process to understand where things are and how they are related to each other. How are binoculars related to the person, the other person in context? Is bat the animal, or sports equipment? But you're able to parallel process context with the transformer architecture, and it's able to pay attention to the input meaning. Again, to both of those examples, if you apply those here, those three things together, it brings the efficiency to the process of generating text and generating unstructured data, which is why transformer architecture became very popular.
yeah. I mean, all these chat GPT, all the models are based on that
Yeah,
only. Yeah.
all the
And
models are using that. When there's just to one more piece on that, it uses encoder decoders. So
mm,
not all models today are using. So there are two versions of this. So this is a simplified version of a transformer architecture, where you have an encoder and a decoder. Sometimes you only need an encoder, and sometimes you only need a decoder. There are use cases for things like that. So if you think
mm,
about sentiment analysis or classification of a negative review and a positive review, you only need the encoder model. An encoder only model can do the job. When you're talking about translation use cases where you have something as an input in, let's say, French, and you want to translate it into English, that's where basically you're changing text to another form. Then you need both encoder and decoder. And then Chat GPT, for example, most GPT models are that where you're generating text. That's a decoder only model. So you only need decoder for those things.
Okay. So also they say like neural networks did not have the self-attention mechanism. That's how the transformer model also came
Exactly.
into
Yeah.
existence.
Yeah. Thanks for mentioning
Through
that
that,
term. The term is important. Self attention,
through
right?
that
Yeah.
research paper, attention is all you need. Is that right?
Yeah.
So yeah, I mean, yeah, yeah. Go ahead. You're telling something.
No, I was just gonna say. So, I didn't highlight the word here. That tension is all you need, right? But that's exactly what the architecture is able to do, which
Yeah.
is it's able to pay attention to. And I don't know if I have that image here. I didn't do that. But if you go back here, I saw the person walking with binoculars, being able to the what attention's able to do is it creates relationship of I with every single word in that sentence, and the things before it and the things after it, right? And so imagine how much context now with this it has. With the context, the attention is, that's what it means. So now I'm able to, just by looking at this much, I'm able to identify whether it's connected to person or me, and that's because of the attention.
Yeah, true.
Yeah.
So yeah, I mean, can you tell us a little bit about how these LLMs are trained?
So train and I don't have a visual for this one, but we'll talk through it. So when you train a large language model, the let me actually bring up this thing here, just for context. So when you're training it, you have the you're taking the data. The data can be in different formats. So you might have data in a table somewhere. The some data is coming in from a database, right? So your data could be in multiple different places. So the first thing that happens is, and this is an exercise when you're working with customers, um, and when you are deploying large language models, you are going to spend like more than 60% of your time on just collecting and making sure the data is clean, right? So
True.
just be aware that that is going to be a huge part of the puzzle. So you collect the data, because the cleaner the data is, the more high quality the data is, the better your model is going to do. So make sure, if you're, for example, if you're creating a large language model um, to make for your customer support queries, you want to have data in there that is from all the years, and to get the model enough context of what types of questions your support staff gets, and all the things about your products, your inventory, things like that. So you need so there I just mentioned like 4 different data sources. So you take all of that data, and then you create data pipeline, clean it up, and then feed that into your give it to your model training team, right? And then the model training team will obviously separate the data into take also a high quality set of data that would be used for instruction tuning. So usually you're not, for most people, most use cases do not require you to train your own model. Okay, you're mostly going to take a model like GPT-4o or or Claude Sonnet, and then do some instruction tuning on that model to make it your own. And by instruction tuning, I mean you're going to take some examples of your use cases. So the customer support example that we're talking about, you're going to to create, let's say, 1,000 use cases, a thousand set of prompts and responses, high quality prompts and responses that a real person, a human's writing. Okay, and that those examples are then going to be used to fine tune that model on top of the 4.0 or whichever base foundational model you're choosing, and then the resulting output that you get for that model is a fine-tuned, instruct-tuned model, and that is now going to be much better at responding to the queries that your customers are going to ask, because now you've given it a lot more additional context of the way way people ask questions to your support staff, or the type of uh, the additional context of the business that you run, right? So that is how they're usually trained. Now there's more elements
Mm.
to this, which is human reinforcement learning,
Mm.
where you also have sometimes a reward model that you use which is using the multiple different humans in the loop who are saying, yes, this response was good, or no, this response was not
Mm.
good, we should modify this response, and then it goes back and feeds that into the loop for the model to update again. But that's roughly how we
It
train
is.
the model. Yeah.
Yeah, yeah. So I think amazing explanation there. So I wanted to ask, like, what happens when a user query is asked in the chat GPT, like an LLM, like
Hmm.
to the chat GPT?
Oh,
What
great question.
exactly happens? Many people want to know
Yeah.
that.
This is like an interview question, right? What happens behind the scenes? Okay, so we'll take this picture as a, because it's a very simplified version of the transformer architecture, but I think it'll do the job for the example. So let's say you put something as an input into ChatGPT using this architecture. Let's run through it. So maybe I said something like the same example. I saw the person walking with binoculars. You type that into ChatGPT, and you want it to complete and give you additional paragraphs beyond it. The first thing that happens when you put that as an input is it converts the in, the machine can only take inputs in the forms of zeros and ones, right? The numbers. So the very first step is tokenization. So the input then converts from words into numbers, and that process, you use tokenization algorithms for that, and that process is called tokenization, and you get a token ID. So, and this could really mean like I walk, every single word basically gets converted into a numerical representation.
Numerical number.
Yeah. Now, once that is done, then it gets fed into the embedding layer. So in the embedding layer, the embeddings are a vector representation of those numbers now. So now you have the input in numbers. Vector representation is, and this is where the semantic meaning comes in. So normally the keyword searches only give you the exact search back, right? When we say semantic search, it gives you meaning of the things. Like if I'm saying I went to watch a movie, that move the context of movie with, maybe I went to watch a movie 2 days ago too, or I watched specific types of movies. Like there might be meaning to that sentence that is beyond just the words that are being used, right? There are lots of things we say where we mean something different, but we say that because it's semantically same, right? So that is why humans are different than machines. But then this is what we try to do with embeddings, where we are trying to map out these words on in a vector representation. So imagine a three-dimensional space where all of these words that we were talking about, I saw the person walking with binoculars, they're all now taking a dot on this vector space. The closer they are to each other in angle. So let's say I saw eye is closer to binoculars than person, and person is, let's say, in a different plane. That means that eye and binoculars are closer together, which means they have some sort of semantically closer meaning to them, and that is what embeddings does. Vector embeddings do, and I'm sure you have better you have more ways of saying this, given single store does vector embeddings. But I'll give it to you, and after just talking about a few more things in that flow. So once you have that vector representation of the input in, and again, I'm just saying it in words, but it's really, again, those numbers are on the three-dimensional plane. It's not a three-dimensional plane, it's a multi-dimensional plane. I'm oversimplifying it to be, let's say it's a three-dimensional plane where these words are then um, placed, and you're finding the closer together words are closer in meaning to each other, or semantically closer to each other in meaning. And then from there, that goes into the encoder. That input then goes into the encoder. And then in the encoder, your it's the encoder is responsible for doing the deep representation and the multi-headed attention that we were talking about earlier, which is it's then able to understand the entire context that's given to it and say, this is how these things map to each other. I know that there's like these many this is how the words rhyme, this is how they connect with each other. That is all happening in encoder. And then in the decoder, uses the encoder's conceptual understanding, and then it generates the next token. That's what the decoder is doing, to generate the next token. And then the softmax output layer, that's where you get the probability of, when we saw the example here, when I was saying the hill, mountain, and tree, the softmax layer is gets that hill, mountain, and tree, the three probable words, and then it picks the most probable word based on the probability distribution, and then spits out that word and says that's the output. The mountain is the output. So that's roughly how things work in the transformer architecture. Once you put an input in and expect an output.
Yeah, sure. I mean, amazing. Yeah, I mean, now that I think many developers will have this question, right? As a developer in the age of AI, what do I need to learn? Like, where should I
Mm.
start from? So, if you can talk a
Yeah,
little bit on that.
I think our jobs as developers are definitely evolving, and evolving pretty rapidly. So understanding that and realizing that, extremely important. I think there are two ways to think about this. There are two big paradigm shifts, right? One is, we all as developers need to be using AI as a part of our development lifecycle. So development, testing, creating any, generating any kind of code, just being able to utilize AI as an assistant in helping us do software development is definitely one, because that will help make us more productive, right? Take the chores away and make us help us use our time efficiently in more involved and exciting tasks. The second is even bigger, which is including AI as a part of all the apps that we work on. So every single app now, or application developers today, have to use AI and incorporate AI into the application. I'm pretty sure already you've come across use cases where the company and the team is like, we need to include Gen AI as a part of this app, that you've worked on for a long time, right? That is becoming more and more normal. You, as developers, we are all going to be asked to incorporate AI and intelligence as a part of our current applications, and this is where the skill around making model choices is important. Being able to uh, understand how models are fine tuned, which we just touched on today, to your specific use case that will work for your for your particular app, right? You're not always going to be the person editing or modifying the model to the use case, because you most likely have ML engineers on the team to do that, but you will be the one consuming that model. So you want to be and we all use APIs as developers to like connect our apps together to different things, which is pretty much how it's going to be. But knowing and being able to make those choices of the right models, fine tuning the model, knowing how that's done, is going to be critical in being a good application developer that understands how to incorporate AI into the mix.
Yeah, nice. I mean, since you have started, I mean, talking a lot about Gen AI and the concepts, so if people want to learn from you, where should they go apart from your LinkedIn bites and videos?
Yes, and we are going to also drop this link in the chat, but I have a Maven course coming up. And I'll give you a little bit of context on what the course is, because um, here, I don't- how do I share it in this?
You can just show that in the there is no way to share it here in
Okay, let me
in
just, okay,
just a
so if I
private chat.
go, here we go. I'm going to do this. If I do that, I
In
can,
your slides.
yeah, I'll put it in this in a new slide here and drop it into the, and then you'll be able to also find it. So let's see. Okay, so I've got a new course coming up on Maven. I've called it Generative AI from Zero to Smart in 3 hours. And here's what I intend to do in it. It's basically going to be what we talked about today is, consider that to be setting the stage, right? Um, I will be talking about the concepts of how do you do fine tuning, what are all the examples that we just touched on, the examples of like a summarization, like, but we'll go into step by step journey of how do you pick a use case, then how do you fine tune the models, and how do you use retrieval augmented generation real in the real time inference phase of the um, of of your use case. Obviously, we'll talk about agents, but everything in context of concepts. I won't talk about products or services at all. I've basically considered this to be like a university course where you actually end up learning what generative AI is and how it works behind the scenes. So you can be somebody who can very smartly talk about a use case, or it's be in any setting, and be smart about Gen AI. So nothing to do with products or services. It's going to be mostly about concepts of, and we'll use some research papers and things like that to understand how fine tuning's done, or how RAG is done, things like that. But that's what I intend to do. I'm starting to think about what fully goes into the course, but that's my intent, and I hope you join me. I'm very excited. This is the first time I'm offering any type of course. I'm very excited for it.
Yeah, I mean, thanks, Devashish. He just dropped that in the link. He just dropped it there.
Thank you, Devashish.
Yeah, I mean, yeah, I mean, we are almost at the end of this session. I just wanted to share like I work at Single Store. As you guys know, it's the fastest SQL database in the world.